everyone, my name is Francesca Gandini and I'm a visitor at Kalamazoo College, which is here in Western Michigan. I work in the field of algebra and my work lies on the intersection between commutative algebra, invariant theory, and representation theory. I like problems or questions that can be studied with a computational approach and hopefully also a combinatorial one. So a big theme of my research is the idea that there are methods that can be transferred from the commutative algebra to non-commutative algebra context using tools from representation theory. And in particular, I've done this for results about regularity that can be transferred from the symmetric algebra to the exterior algebra via their analysis as polynomial functors. So this connection brings me to looking at a classical field in commutative algebra, which is invariant theory, in a new context. So invariant theory was a motivational field for a lot of historic commutative algebraists, or even before they were called commutative algebraists, like Emmy Noether. And one beautiful result in our work is that if one considers the invariant ring for the action of a finite group in characteristic 0, then the invariant ring is generated in degree at most the order of the group. And our approach was actually ahead of the times in the way in which there was a constructive element to that proof. And nowadays, with the advent of the age of the computers, invariant theory has found a second life in what's called now constructive invariant theory, in which we use computational methods and degree bounds to find invariants, or at least bound them. And the fact that Noether bounds exist is actually one first step in the computational direction. My work establishes the foundation of methods for constructive invariant theory, but now in the exterior algebra context. So, for example, what I did, I used my work on the regularity bounds of the exterior algebra to establish that Noether degree bound also holds in the exterior algebra. So if you consider an invariant ring under the actual finite group, now of skew polynomials, still the degree of the generators can be bounded above by the order of the group. So that gives a leeway for having constructive methods in non-commutative algebra and non-commutative invariant theory in particular. In general, problems in non-commutative invariant theory can be hard to tackle, but my hope is that via the exterior algebra as a liaison to the non-commutative world, we'll be able to see what problems are mild in the non-commutative world, so they can be actually approached and they can be tractable, possibly with tools from non-commutative algebra. I hope to see you all at my talk. Bye-bye.